Hi, I'm David Somerville. Hey, my next project is going to be to create a IoT-based network capability probe. It's something I've done in the past. In the old days, I used ASP.NET and Windows services to act as a probe and was able to control them across the network and be able to collect details about network latency and bandwidth. This time I want to use a different sort of probe. I want to use a microcontroller, one because they're really cheap, and then it gives me a lot of flexibility about placement. I can put them just about anywhere. They're low cost and easy to put somewhere. They're self-contained, don't have to worry about anything else touching them. So the one I'm looking at is something like this. This is a ESP32. There's lots of different boards you can get for doing this that are both ESP32 based and use other microcontrollers. So that's what I'm looking to do. Some of the challenges I see and what makes this interesting is I haven't written microcontroller software before, so that'll be interesting to work out how to set up the tool set, what you actually need to do for coding on a microcontroller that doesn't have a real OS underneath it. How to do the hardware. So at the moment I've got it just on a breadboard, but eventually I want to package it up and put it in some sort of box, or maybe even a power plug. If everything could go on a power plug, just plug it in and you've got your probe running without anything else being needed. I've got to think about what buttons I need, whether I need any control panel or display on the microcontroller to do things like set up the Wi-Fi, or maybe I can do it through Bluetooth. So that's going to be the main challenge. The other thing is I'm going to be using IoT Core from Google. Mainly that's because I've been doing a lot of work in Firebase, Firestore, kind of all the different Google Cloud platform services, and been doing user interfaces in Angular. So it really makes sense to, once I get the data, to use a capability that's in Google's cloud infrastructure to also collect the data from these probes. And IoT Core looks like it'll do the job for me. Looks like it'll do a pretty good job for me. I guess the last thing that is going to make this interesting is once I've got the data in a Firestore database, is what to do with it, is using some of the big data capabilities of the Google services. So either looking at the data across different probes and different environments, and also with the Angular UI interfaces, what's the best way to set it up. And like I said in the past, I did a simple interface for when I did this before on a Microsoft environment, but there's a lot more options with Angular and some of the Google and Angular libraries for displaying data. So I'm going to walk through a bit of more detail on the project, and then the next blogs will start going through the different parts that make up this project.
Okay, so a closer look at the project. Like I said, I've done this in the past where I've set up probes and collected data about network capabilities. So example of the data that gets collected is shown here. This is I used to do it in an SQL database, but things like latency, bits per second between the probe and whatever's been checked for. This used ICMP in the past. My new probes will also use ICMP to get bits per second and network latency. So what's new? So before, the probes I'd put together were using a Windows service, or ran as a Windows service. It's okay for running on Windows, but I wanted something a bit more portable, a bit more general to use in the future. So what I'm thinking for the next probe is to use a microcontroller, so it can sort of stand alone, do its thing, and report back to some central service with all the data it's collecting. I've been doing some development, or I've been doing a lot of development in Firebase, so I like Firebase is a way to develop the UI and the Google services to basically have a unmanaged serverless environment. If I carry on that way, then what I'll be using is the Google Cloud IoT Core. So this diagram just shows the overall architecture. So you see from Cloud IoT Core, which is a service that provides device management for things like microcontrollers, IoT devices, authentication services, make sure that what you think is the probe actually is, so identity management of the probe, monitoring of the probes that are out there, and acts as a data broker, so collects the data that's sent from the probe, and using the Google Cloud PubSub service can publish that data into where I want it to go, into a Firebase or Firestore database to be processed and used in an Angular UI after that. The probes will communicate with the IoT core using the MQTT protocol, and I'm thinking the probe's going to be an ESP32 because that has a microcontroller with network capabilities built into the device. So just running through the high-level requirements. So as I said, Lupin Enterprise probe capabilities. I want it to have centralized management and be able to collect network capabilities from probes. And it's kind of what I had in the past with Lupin Enterprise Probe, my old version of this. So this new version, ourProbes, will have similar functionality. So I don't need to run through all the requirements again. But we'll have the addition of being able to run on different hardware types for the probe. I want to have generalized probes, so what I develop in this case for microcontroller, I want to be able to swap out those probes with, say, a probe I develop on, say, a Linux Pi type hardware, which would be a bit more upscale. It'd have an OS on the probe, and also still be able to support things like Windows services running as probes, to be able to not be restricted by the sort of probe or device that I can install the probe software on. And I also want some extensibility. So like I said in the past, this was mainly just doing network capability measurements of latency and bandwidth, but it'd be nice to be able to also do some tests through other network protocols, so things like HTTP, and HTTPS, to be able to do timings on websites, time to the first page, and just availability of websites. So that'd be a nice a capability to add to the probe. Be able to do things like QoS timing, so set QoS bits in the network packets to see differences in capabilities under different QoS options. Maybe doing some other protocol tests. So this would be a bit harder, but things like doing voice over IP tests, real-time protocol tests on network capabilities as well. The high-level architecture definition. So because I'm using, I'm going to be using Angular and the Google Cloud services and Firebase, it sort of leads me down the path of going to Google IoT as the interface to the devices. So I won't be making any changes to that. The other thing I wanted to do is choose what probe platform I'll start on. There's an awful lot of microcontrollers and capabilities and languages you can run on those devices. So I went through a decision analysis and resolution process. So if you haven't seen, that's another project I've just finished with, our DARS. So you'll see the results of that, where I went through and did a formal analysis of the different solutions or different types of probes I might want to choose, and had a set of criteria I wanted to use to decide which was the best one in my case. Planning, fairly high level plan here. So I want to get the IoT core set up in Google. I haven't done that yet, so that'll be one of the blogs that I put together showing how I set up IoT, the registries for that, getting the PubSub going. testing that the IoT's core is set up correctly. I want to do a probe POC, so whatever probe I decide, I want to do everything from setting up getting the microcontroller, getting the hardware set up, getting the tooling set up that I'm going to use with that probe, getting the IoT core integration, so being able to communicate to the Google IoT core service, and getting some ICMP based measurements being sent up to the Google services. After that, I want to be able to set up the data broker from IoT to Firestore. I haven't done that before, so it'd be interesting to run through the process of doing that. And then doing the probe management from Firestore. So I want to be able to do things like remotely tell the probes what network connections it should be probing. So being able to do that centrally and then just have it distributed out to the probes to perform those measurements will be great. That's kind of the general plan. Then after that, I've got a production plan. So once I've got those first 4 things done, then I'll be pretty well set to turn it into a better defined system. So clean up the deliverables from earlier, the high-level POC plan. I need to develop the Angular UI. I'm not quite sure what that will look like. I'll probably be using some of the data analysis tools and libraries that you can add into Angular to show things in charts, and being able to do interactive analysis on the data, and do all the good things like setting up Cypress end-to-end tests to be able to test what I've developed in Angular, create a manual, create all the tutorials about the finished product when I've finished with it. This is open to change, so we'll see how that goes. Okay, so showing the DAR or decision analysis that I did on deciding which probe I'll choose, or probe architecture I'll use. You see the choices down here under solutions. My choices were Raspberry Pi and MQTT interface. I could have used a Arduino, just a straight Arduino type device, and C++. Another choice is ESP32, which is a particular type of microcontroller that has the wireless networking, or has networking built into it, and use that with MicroPython as the development language, which will drive a lot of the tooling. The other choice with the ESP32 is use JavaScript and Mongoose OS on the device, which seems a popular choice as well. Just going on, so looking at the criteria I used, I wanted a strong community and support available for whatever I choose, because I'll probably be going out to the internet quite often to fix some of my problems. I want to make sure it's future-proof, that it's not the end of the line for this particular hardware choice or the language choice, that it's actually building, and I've got a history of seeing changes over time with it. Must be secure hardware and software, so I don't want to build this and find that anyone can get in and wreak havoc with my probes or the data going into the IoT. So for sure we need to have secure hardware and software. You see that's a critical waiting for that. I need to be able to send variable length ICMP echo timings from the device. The way I get the bandwidth and latency is using a Bing algorithm based on timings for different length ICMP pings. I can work out the bandwidth or available bandwidth on a connection. Must support an MQTT interface, because that's what I'll be using with the IoT core. Must or should have other network capabilities. Like I said, I want to be able to extend it to do things like set QoS bits, do tests on network protocols other than ICMP. Must be low cost. I want to be able to put a few of these probes out, so I don't want to be spending a lot of money on the probe and any hardware or software that needs to go on those probes. As well, it has to be centralized, easy management, and needs to be reliable and accurate. I don't want to have to keep restarting these probes. They should just run and be able to forget about them, just manage them centrally. So there's the the choices I had, and you'll see in here the solution evaluation matrix that comes out of when I do an evaluation in our DARs. This kind of shows me which one was the winner, which in this case was the ESP32 and MicroPython. I think ESP32 and JavaScript and Mongoose OS would be fairly close as well. It kind of lost out because there's only one vendor of Mongoose OS, and if you get a lot of probes, then you start having to pay licensing fees. Also, the community and support for that didn't seem as large as the MicroPython based one. And another choice was that came in close was the Arduino and C++. Mainly it lost out. It had most of the same capabilities as MicroPython, but just my unfamiliarity with coding in C++, I'd have to get up to speed with that again. And that it's a lower level language than MicroPython. Reduce things like being reliable and accurate, centralized, lightweight management. It's just going to be a lot more work for me to put those things in place in C++ and make sure my coding's actually working. So I preferred sort of a higher level language like MicroPython is the main difference between these two choices. And lastly, Raspberry Pi really lost out because it's harder to secure, and the costs are always going to be higher than I budgeted for put a Pi and a case and power supply together. We're looking at about $50 per device, which was more than I had in my criteria, so it lost out just because of that. As well as a low security too is harder to secure a Raspberry Pi just because it's a more fully featured OS and there's more to secure on it. So finally, just to look at some of the devices I was looking at. So I'm deciding on using the ESP32 based on that DAR. Up in the top left-hand corner here, you see the actual device that I'm starting this on. There's a lot of development boards that are available that use this ESP32 chip, and just showing some of the other options here. So top right hand side, you can see you can get things like micro versions of the same capabilities in the ESP32 chip. This one's really small, so one thing I'd like to investigate is whether I can put this probe in some sort of power plug and just plug the whole thing into the wall, so rather than have a separate box. So something like this MicroPython device might be a good option for that sort of hardware. Down the bottom here, there's ESP32 boards that have things like a display on board already built into it. That might be useful. One challenge to this will be setting up the initial connection to the network. So you'll need to be able to enter things like the SID and the Wi-Fi password. So having a display will make that easier. There's more complete ESP32 solutions out here. I think this is a M5 stack. This box is called. So this is kind of a whole collection of boards and software, mainly on the educational sort of things. But it's just a nice box. When you look at it, it's got a display, got some buttons on it, so it would be useful for setting up things like Wi-Fi connections just from the box. And finally, I may want to be able to do network checks across hardwired Ethernet rather than do everything through Wi-Fi. So you see there are boards out there, such as this one, which has the ESP32 chip for doing the Wi-Fi side of things, but also supports doing networking through an Ethernet port, so you can hardwire it in. So an option like that might be something that I want to use for some hardware as well, in cases where I don't want to do things over Wi-Fi. So finally, just the next steps here. So these are some of the activities I'll be doing. I'll document them in separate blogs. So probably next up, I'll set up the Google I/O core project and Google I/O cloud services. Walk through doing that. Set up things like the microcontroller tooling. So as the DARs selected ESP32 and MicroPython, I need to set up the tooling to get code onto the microcontroller, choose the microcontroller, those sort of things. I'll walk through that. I need to get the microcontroller connected to the IoT core. I know there's libraries out there for ESP32 and MicroPython for doing that, so I need to walk through, actually get that going, see if there's anything I need to add in to manage those libraries. And also need to add in the code, or the MicroPython code, that's going to do the network capability check. So being able to do ICMP echo requests of different lengths, collecting that data, and also sending that to the IoT core.